Okay, so here let's look at these equations, and we are basically looking at some classification of equations. Now, equations are in the form of exponents can be regarded as the Diophantine equation. So, Diophantine equation is a polynomial equation where only integer solutions are sought. So, we try to look for integer solutions. So, they trigger integer solutions. We also have exponential equations, which is an equation where variables are in power or maybe in index. We have we have the indeterminate equations, or maybe the multivariable equations, because there are two variables. We can take n and m to be two variables, but only one equations. There is no single unique solution without further constraint like requiring n or maybe m to be positive integers. So let's look at these Diophantine equations. So we are taking Diophantine equations. Okay, so let's take equations that in regard to Diophantine and see how you are supposed to handle it. Let's say that I give you equation. If 2 to the power n plus maybe 2 to the power m is equal to 40, and I ask you to find what is n plus m. N plus m is equal to what? So this is what we regard as Diophantine equations. Equations in this manner. Okay. So what is n plus m? Diophantine equations. And I have said that only integers solutions are triggered. So this is the way to handle this. So we have 2 to the power n plus 2 to the power m. So we are told that this is equal to 40, right? So what does that mean? We can look for two values that we can multiply to get 40, right? And I can think of maybe 8 plus 8 times 5, right? So I can say that 2 power n plus 2 power m is nothing but 8. So this is 8 multiplied by 5. I can further divide 5 by saying that 2 power n plus maybe 2 power m is equal to 8. Then I can have it as 4 plus 1, because I know 4 plus 1 is 5. And then I can try to reduce this again in order to get 0. You keep on reducing this to the lowest. So I have 2 power n plus 2 power m. So this can as well be reduced to 2 power 3, which will give me 8, into 2 power 2, which will give me 4. That will give me 4. So 2 power 2, then we have for 1, we can have it as 2 power 0. So this implies that our 2 power n plus 2 power m will be what? This is 2 power 3, so we can have 2 power 3 plus 2. And here, so this is addition. Here we can have it as 2 power 3 plus 0, because here we have 0, equal sign. So, if I continue, I will have my 2 power n plus 2, 2 power n plus 2 power m to be equals to, here we have 5, because 3 plus 2 gives me 5, and plus 3 plus 0 in this side. Okay, so now that I have 2 power n plus 2 power m to be equals to 5 plus 3, we say that only integer solutions are triggered or are sought. So what I will conclude here is that I can write hence n is equal to 5 and m is equal to 3. So we are told n plus m is equal to what? So n plus m is nothing but 5 plus 3. So this gives you 8. So 8 is the solution. And this is how you solve Diophantine equations. So the Diophantine equations gives you integer solutions.